Hey there, Year 11. So in this exercise here, this exercise 4E, in the past we haven't done it before, so this is my first time recording it to explain how to do circles. Now, if you watch the other videos on 4A, B, D, or even C, then you would have got a general idea of how to use transformations for different functions. Now, circles are similar in the exact same way, except the format's slightly different. So here's the format for a circle. Okay, so a circle will look of the form, you don't have to write this down, x squared plus y squared is equal to r squared. Okay, the x will, just like what you've learned so far, anything to do with the x, that is the horizontal transformation. Okay, so horizontal. Whilst anything that affects the y, that is anything to do with the vertical transformation. Okay, and then r is your radius, so it dictates how wide the circle is going to be. So here's a very simple example of a circle. Center with a radius of 1, so r equals 1. Actually, I'll do r equals 3 for now. So that means r squared would be 9. Okay. And to have the circle, if I just typed in x squared plus y squared, that will determine that the center does not move left or right, because that's a horizontal transformation, right? So it doesn't move left or right, no horizontal, no h, and there's no y, or no k, if that helps you memorize the transformation. So that means the center of this graph does not move left or right, and that means it's at 0, 0. So here's an example that you can look at Desmos. So if I type in x squared plus y squared, y squared, and then I type in equals, right? But here if I put 9, and let's put on the grid. If I put on the grid, you can see with the axis numbers, I'm going to take the minor grids off and zoom in a bit. And there you go. You can see that the radius is from 0 to 3. So the radius is 3. And if you look at the center of the circle is clearly at 0, 0. I'll just label it right at 0, 0. So just like what you've learned so far in all the other exercises, 4A, B, D, the transformations, if I want to move this left or right, what you do to the x determines if it moves left or right. So here's an example. If I take the circle, so x, right, but if I say minus 1 and then I do a square, we know that we've learnt that the x minus 1 will move it to the right by 1. Plus, and again, in the y form, let's just keep everything the same. Let's just keep it as y squared. I'll keep it 9 as well. Can you see how what I've just done is I've shifted the purple graph. Actually, I'll make it red so it's more obvious to see. Let's make that red. Okay. Can you see the red graph, how the center now has shifted from 0, 0 to 0, 1. That's where, whoops, not 0, 1, 1, 0. 1, 0. It has shifted the graph to the right. Can you see that? So if I take that off, is that easier to see? And because it's shifted to the right by 1, so originally it was at 0, 0, it's now moved to 1, 0. Can you see that the radius is still 3, because 1 plus 3 gets you the maximum length of 4 on the side, and then to the left by 3 gives you negative 2. So if I put back the original circle, that's my original circle there. So that means whatever you change in x minus 1, just like how you, in the x bracket, just like how you did on all the other exercises, it will move it left or right. So you can see here that if I changed it and I called it A, and I add a slider to it, and you see if A was a minus 1, whoops, where's my slider? I'll just go negative 10 to 10, and let's say step 1. You can see that if I go to minus 1, it moves to the right. If I go to minus 2, it moves to the right again, to the right again, to the right again. And you can see that if I zoom out, you can tell that the more I go in the minus, so if it's minus 7, x minus 7, moves to the right by 7. So the center should be at 7, 0, which is right at the center there. You see that? Okay, and then similarly, the y component is what goes up and down. So just for you to visualize again horizontally, if I just press play, you can see that the graph is just shifting left and right as I'm changing the numbers. So when it's plus, it moves to the left. When it's minus, it moves to the right. Yeah, just like all the other graphs that we've been doing. All right. Now I'm going to pause that, and I'm going to make this 0. So let's make no left or right. So the red circle's back to the center again. Now let's say I affect the y. So if I put a plus b, put a slider in, and you can see here again, I'll do -10 to 10, step with moving up and down by 1 unit. So you can see here, b dictates. If I do plus +5, so it's y plus 5, you can see that it shifts down. The coordinate now becomes, the center is now at 0, -5. See that center? And that's because I'm essentially writing this plus b. What if the b was a +5? And that's why it's shifted down. And notice that if it was -5 on the other hand, so if I move this all the way to -5, you see that? -5, so if it's y -5, it goes up. And hence my center is now at 0,5. In fact, I should just call it 0b, and you'll see that if I just move this, actually 0 -b, just so that it matches, you can see that the center just changes along. So it starts off 0, 0, and when b is -5, it goes, so if b is 5, then the negative of 5 is -5, and it goes down here. Okay, so essentially this is your circle format, and whatever you change to the x makes it a horizontal transformation. Whatever you do to the y is a vertical transformation, and whatever you change to this r is the radius. So if I made it 25, makes it a bigger circle, means that the radius is 5 units. Okay, and then if I made it 36, then it's a radius of 6 units. Cool? All right, so that's the general idea of what this exercise is going to be about. We'll start off there, and then a couple of other notes here. You can also have semicircles right here. So these are your 2 semicircles. And how do they get this equation here? That's your semicircle equation. I'm just going to highlight that for you. So this is your semicircle. So you can have the top half of a semicircle. Okay, so that's a semicircle there. You can have the top half. That would be y equals to the positive square root of r squared minus x squared, whilst the bottom half of the circle is then y equals negative square root of r squared minus x squared. Now what's interesting as well is that you can do the same rearrangement of the original equation, because remember the original equation was x squared plus y squared equals r squared. All it is if you just rearrange it, you can actually even get the 2 vertical halves as well. You can get it like this. And that's what these 2 equations here represent. So if I highlight this one now, this one are your 2 vertical halves. So you can have the left half and you can have the right half. And it's the same concept as well. This one would be the x is equal to, because it's on the positive side. Apologies there, I'm sitting at school and the bell just went. So x equals 2, it's the positive root, in this case it's r squared minus y squared. And then the left-hand side will be x equals negative root of r squared minus y squared. Okay, so that might be some helpful notes just as a general theory for you. It's all summarized in this section here, but just watch this video as a sense of understanding how it works. Now I'll show you what it looks like in Desmos. So I'm just going to delete all of these so that you don't get confused. Okay, so we learned about circles. Let's look at semicircles now. So if I did y equals positive square root, okay, and remember it's r squared, so your radius squared minus your x squared, right? But I need to give r a number. Let's call it, let's do 9 again. So radius of 3. And I zoom in. Can you see how it's the top half? But if I change this to be a minus, then it's the bottom half, right? And if I change this to x and I change this to y squared, can you see because it's a negative, then x is negative on the left-hand side. And if I want it to be a positive, I can, let me just copy all of this. Copy, paste, and I'll change that to a positive. And you can see together, that's your two halves there. Okay? And that's your semicircle. And then if I just want the full circle, it'll be x squared plus y squared is equal to 9. And that's my exact full circle in blue there. So if I took off the blue, you can see the green and the red. And turn blue on again, and then that's the full circle. Okay, so if you're wondering how they got this semicircle equation, the proof is already here, or I can quickly show you here. All it is just a quick rearrangement. X squared plus y squared is equal to r squared. So if you move the x squared across, then you subtract x squared on both sides. X squared minus x squared cancels out. You end up with y squared is equal to r squared minus x squared. And then to get y, the equation in terms of y, you square root both sides. So square root, you get r squared minus x squared. But remember, when you square root, you get a plus and a minus. And that's what the plus minus represents. You've rearranged it. The plus is the top half. And the negative for the y is the bottom half. And similarly, if you did the same thing instead of moving the x squared, but if you move the y squared, that's how you get the second equation. You get x is equal to plus minus root r squared minus y squared, and that's why it tells you it's the other two halves. So you've got these other two halves, where this is the negative side and that's the positive side. And that's it. That's it for the theory for exercise 4E. Please watch my examples. I haven't done the videos just yet, but I'm going to do the videos for each of these examples just so that you have an idea of how to work with circles. Okay?